Welcome everybody, I'm Domenico Cipriani and today's workshop is about programming music and synthesizers on the fly with Pharo. I think you already have here a QR code to go to the GitHub repo with the slides and links about today's workshop. But I think that the most interesting stuff to do at the beginning is to listen a little bit of a performance. So okay, so this was a very quick performance. I'm going to perform also tomorrow at the 0 Degrees event. So there will be a couple of live coders and we will do some live coding. I will be performing with Coypu and Pharo. So this is a temporary agenda because we're going to see what we're going to do. But the idea is that in the first 45 minutes, we talk about what is live coding and what is Pharo. Then we talk about Coypu, it is this API and library to do live coding with Pharo. And then we do a little coffee break and we come back to Fausto, that is also a library and API to program DSP with Pharo. Then we will try to make a little performance together. And if we have time, we will see how to design a visual interface for our synthesizer and for our performance. So it will be a lot of things, I guess, because I suppose you're all new to this, because this thing is very new. Yeah, the goals are that you become friends with live coding, programming music on the fly, you understand what it is and why I think it's cool. You meet Pharo, Coypu, and Fausto, so this tool, we understand how to create the melodies, how to do the synthesizer, and then we see. Coypu and Fausto are still in an alpha stage, so there could be like tweaks or pressures, but I appreciate you are here, and I think together with you, we can make it better, and maybe in a few years, there will be more people using Coypu and Fausto, so you are between the first and use them. Also, I think that I really appreciate that you are here today because today we are learning to do useless. We are learning to do useless stuff. Okay, all the other workshops are about making something that maybe you can make money with or get a job. With this, you can have fun, but this doesn't mean that you can also make money with this, because maybe you can get a job like a Pharo programmer, or also you can use Fausto to prototype DSP, so this could be useful for other discoveries. A few words about me, just a few. At the beginning, I was a DJ and live performer. I played all around the world. I had an MA in linguistics, so not in computer science. During the pandemics, I began to develop some plugins and application for iOS. And then I was using Pharo a lot, and currently I'm researching computer music for the EBREF team of IRIA, that is the National Institute for Research on Computer Science in France, with the EBREF team. Also, I am an educator, and I'm collaborating with the Italian distribution of Electron Machine. Do you know Electron Machine? Yeah. Yes. So what is live coding? Are you familiar with live coding? Everybody. No. So live coding is essentially doing the act of doing music or visual or even poetry with coding live. There is this beautiful book, Live Coding a User Manual, that is free, is online. There is the link on the repo. There are a lot of interesting interviews with live coders, artists, and what is what really matters for the authors is to not give a fixed definition of live coding. Okay, because they say live coding is a way of interacting with the world and is a kind of mind setup. So there are a lot of values that come with live coding. Is not only about making music with programming language, but it's also what really matters is diversity and accessibility, and also a kind of an anti-competition practice. Are you a musician? Are you doing music? Have you performed live sometime? You know, usually in the world of clubs or venues, there is a lot of competition, a lot of pressure, and in the live coding events, both conferences and what they are calling algorithms, what matters is the sense of community. So everybody can participate and everybody can express themselves. And there is not the sense I'm better than you, you're better than me, or there is an headliner. They are all on the same page. Everybody is doing different kind of music. And also every time an event is set up, they are really looking about diversity, and they give the possibility also to people of community that are less represented to be presented at the performance. So with live coding comes all this stuff. It comes this sense of community, this stress on diversity and accessibility, and also this anti-capitalist kind of practice. And this is why there is no really a fixed definition. There is this organization, Top Lab, that is organizing and making, helping the proliferation of live coding around the world. There is the link in the repo, and there are a lot of regional nodes. So maybe you can find the Top Lab node closer to where you live. There are everywhere from Indonesia to Italy, Spain, Mexico, UK, Germany. There are a couple, Barcelona, a lot. So with this Top Lab, especially Telegram channel or Signal, you can have the news about the live coding community and participate to events. There is a conference that is the International Live Coding Conference that is 10 years old this year and is really nice. There is also some publication, papers, research. And then it comes together with this, come the Top Lab manifesto that is still in draft. And what is essential is to give access to the performance screen. So when you go to a live coding event, there is always, the screen is being projected. So there is also this kind of thing that the artist can be tricking you, okay? So traditional musician cannot trick the audience so easily, because if you play guitar, you play the guitar. If you play the drum, you play the drum. But if you go to some kind of electronic music event, you see that DJ now with beat sync and this kind of stuff, they can really trick. So the idea is that the showing the screen is also showing the thoughts. And then it comes together with the concept of algorithm that born in London 15 years ago. They're making a lot of these algorithms, and the algorithms events usually are night events, and they are focusing repetitive conditions, as they say, so kind of repetitive music. And they are doing that everywhere. Have you ever been to an algorithm somewhere? Where?
Here, outside here. In the UK.
Nice. Yeah. And there are many programming languages to do live coding. Here there is a very short list, but there is a link where to the all things about live coding repo, where you can find there are like, I don't know, at least 50 listed maybe. Here a short list of the most used. There is like tidal cycles. Have you ever heard about tidal cycle? So tidal cycles is the most used probably, and is Haskell based. You know Haskell? Something. A question that maybe is important. Are you all audio programmers? I guess, or future audio programmers, or audio engineers? Probably. Yeah. Which language are you using? Program? C++. And Pharo. What kind of C++ programming? Okay. Okay. Python. Okay. So here you can find, in this list, there are like, example, Tidal is Haskell based, so Haskell is a functional language, and is kind of, for me, difficult to learn. It's very expressive, and this guy, Alex McLean, that invented that give a shape to the line coding movement is doing a lot of work with tidal cycles, so it's very spread. And usually when you go to an algorithm or to a line coding performance, most of the people are using tidal cycles. But then there is, for example, Chuck was actually the first language. Have you ever heard about Chuck? So Chuck is an object-oriented language, C-like, that was developed by Gail Wang at Princeton University in 2008, and now is maintained by the Stanford University and Karma. And it's really for on-the-fly sound synthesis and composition. So there is a virtual machine. You can load your synthesizer, and then you can play live. And so it was really the first one about programming on the fly. Also, the on the fly definition comes from a paper of Wang and Perry Cook. Then, for example, there is Sonic Pi. I don't know if you ever heard of Sonic Pi. Sonic Pi is also very diffuse. It's kind of easy to learn. It's Ruby based. I know Ruby. So object oriented also. And then there is, for example, Orca. Orca is kind of very esoteric because it's grid based. There is like very few symbols, so it's very obscure. Then there is Strudel, that is a web version of Tidal Cycle based on JavaScript. So it's very easy to use because it's on the web. There is a lot of learning resources. Then there is Foxdot for those using Python. That is a way to interact with Super Collider. You know Super Collider? And there is also Sardine, that is kind of a port of tidal cycles for Python. So if somebody want to use Python-based language, and then there are other, like Mercury is very easy to use. It is also on the web browser. And then, for example, we have Hydra. I don't know how many of you have heard about Hydra. Hydra is used for visual. It's a visual synthesizer. So many times when you go to see a live coding performance, sometimes there are more than one artist on the stage, and one is doing music, the other is doing visual. Somebody sometimes is doing poetry, also live. It's very interesting. And the idea is that today I am presenting Coypu because I'm working with Coypu and with Pharo. But the idea is that if you like Coypu, you continue to use Coypu. I'm very happy. But if you like something else, it's just the concept of making music with programming and having fun with programming. Okay.
Hey, that's simple. There's like Tidal cycles of the language, but it probably have something like a kernel, like a runtime thing. because if you said it's brutal, it's like chaos would be.
Yeah.
So then if Dino cycles to the language, like it has to be, it also has something that runs that has to go.
Yeah.
Translate to audio. So what kind of like runtime engine is Dino cycle based on?
Tidal Cycle, you have to download an Haskell compiler,
Yeah.
and then you can use it from the command line, or you can use it like as an extension from, I don't know if it's for VS Code, but for sure for Pulsar, for example. So Tidal Cycle is just like a client, like Coypu.
And that kind of
And the backend usually is super collided with an audio engine that is called SuperVert.
yeah.
So Tidal Cycle doesn't make any sound. Like Coypu doesn't make any sound.
Yeah. But with what?
Coypu is with Fausto. Yeah, Fausto is a part of with Coypu. And the idea of Strudel, for example, is running on web audio.
Yeah.
So they kind of replicate the syntax of Tidal Cycle for what they could, and then using the web audio backend. So it's mostly sample based, and they implemented a few synthesizer. So of this list, like Chuck can make sounds alone, and Mercury is also like a client. And so really just Chuck is for like really sound and composition. No? I don't know if you are familiar with C sound.
Yeah.
Yeah. So in C sound, you have this traditional concept of score and orchestra. No? So score is writing by the music, and orchestra is the instruments performing the score. And the same things happen for Tidal Cycle. Tidal Cycle is the score, and Super Dirty is the orchestra, and the same for Coypu and Fausto. So Fausto is the orchestra, and Coypu is the score. This is a little overlook. So we have Pharo. Pharo is a general purpose language. How many of you have were familiar with Pharo before this workshop? Oh, don't worry. It's normal. It happens. It's very, I would say, it's kind of a niche for the moment language that comes from Smalltalk. How many of you heard in their life about Smalltalk? Yeah, quite a few. So Smalltalk was developed at the Xerox Park in Palo Alto at the end of the 70s by a group of people, between them Alan Kay, Dan Ingalls, Adele Goldberg, and Ted Keller. Here on the picture, Alan Kay, Dan Ingalls, and Adele Goldberg. And was designed for educational principles in mind, the educational principles of constructionism. So constructionism is a theory of learning by Piaget that is focused on make people learn by doing things themselves. Okay, so at the Xerox Park, these people, the learning research group, first they were developing this kind of first laptop called Dynabook. I don't know if you somebody heard about it. There was the Dynabook, and there was Smalltalk that came to teach children to code, or people with no coding literacy. It was influenced by Simula, that was the first object-oriented language. I don't know if you ever heard about Simula, but every object-oriented language has a due with Simula because it was the first one, C++ or Python. Every object-oriented language has that with Simula. What is different about Smalltalk is that it also comes with an IDE that you can inspect and modify. So the news today will be to see an IDE that is different from the traditional IDE. I guess everybody using what VS Code, Vim, Xcode. It's kind of different because it is very lively already. Smalltalk programs are compiled into bytecode and interpreted by a virtual machine. Okay, and Pharo comes from a fork, was born as a fork of Squeak Smalltalk. So Smalltalk at the beginning was closed source and paid program, commercial product, so very expensive. We kind of very restrictive licenses. The main company using the main company selling Smalltalk was Syncom. They have these visual works and object works named Smalltalk. But then the people of the traditional people of the learning research group, they did Squeak, that is a free and open source Smalltalk. You can see it's still alive a little bit. And from a fork of Squeak by Stéphane Ducasse and Marcus Denker at INRIA in Lille, in the north of France, they developed Pharo. And the idea was to make a modern Smalltalk. And we free open source, and we developed and maintained also by the community, where there is a vibrant community and a lot of people that are working with Pharo. What comes also with Pharo is integrated Git support and a framework for S-unit tests. So with the IDE, you can push and pull and do things with your repository, and also do a lot of text. Actually, in the resources, there is the Pharo Massive Online course. That is the main resource to learn Pharo. There are also many books that you can find online. The massive online course is supposed to be done in 7 weeks. I think you can do it in free if you want. And it's everything you need to know about Pharo with all this stuff. And a few words about why Pharo, why I decided to use Pharo. Actually, I was making music with machines, just recording to a DAW, Pro Tools, so for a lot of years. I didn't want to use computers. Then I was listening to this guy on the right, on the left. Is Christian Walken. I don't know if anybody of you know the music of Christian Walken. Okay. And he was performing with this thing called Kima. Anybody knows about Kima? So Kima, Kima is a programming language that comes with a DSP. The latest version is called Pacamara. Before it was Pacarana, and before it was Capybara. So all rodents. That's why Coypu has this name. You know what is a Coypu? The Coypu is in Italian is nutria. Is this little thing that looks like a castor? Castor. Okay, these are animals that lives in the. It comes from South America, but was imported to Italy to make furs in the 80s, and then it was abandoned because the fur market collapsed, and so they abandoned the Coypus everywhere. So we are full of Coypus over here. Yeah, so he was using Kima. Kima is a programming language that, you know, if you've seen on the picture, look at the picture in the middle, it looks like a little bit like Max MSP, kind of, no? It's data flow. So you connect sounds, you have sounds, like, I don't know, you have oscillators, bank of oscillators, you have filters, and you connect it. But the thing is that you can also write code on the fields. So you have like the frequency field, and you can write an expression that can be evaluated in real time. And in Kima is written in Smalltalk. It has its own dialect that is called Capybara. Last year, who was last year here at the ADC? There was the keynote by Carla Scanetti, that is the inventor, the creator of Kima, together with Kurt Eben. And so Christian was using Kima. I thought, okay, I must have this thing. And I started to learn Smalltalk. But then you can write your own tools with Kima, but it's very close because the system itself is closed source. So it was impossible for me to develop a tool for programming music on the fly. was kind of impossible. I couldn't define my own classes, my own method. And so I started to learn Pharo, and with Pharo, I developed Coypu. This is an overlook at the Pharo ID, where we have many tools. Let me jump to the Pharo itself. Have you downloaded Pharo? Yeah. So we have many windows with Pharo. Pharo is like that, no? So today it will be impossible to learn all about Pharo. Of course, it will be impossible to learn all about Coypu or Fausto, but I would like to give you an overview of everything. And then if you like, you can continue your learning journey. So in Pharo, there is this thing called playground, where you can open with Command OP, or here where there is browse and there is playground. Okay. So the playground is where you write scripts of Pharo code and that you can execute in real time. Like, for example, if we want script open, and then we press Command D, Control D on Windows, and you open a track script. An image of Pharo contains all the state of all the objects and all the classes that you have in the system. So when you save your classes, they are all in your image, and you run the image with the Pharo launcher that is written in Pharo, like everything in Pharo is written in Pharo, also it's virtual machine. And once you got it, you can open it also. And here we can see what is different, no? From the traditional language that everybody use is very kind. We don't have dots. We don't have parentheses for arguments. We have everything happens sending messages to object. Okay. So here what we send with Command D, we evaluate, we send the message open to the transcript that is kind of a logger. And we send it to the class because this is a singleton, so there is just a transcript in the word of Pharo. And for example, we have this Command D, or we can do like 3 + 5, and we can press Command P or Control P, and this is printing. So we can see what happens. Yes, comments is with double quote. Yeah, now we will go to everything in just a bit, but this is a comment, and these, for example, arrays with an hash, and we have like, we can put like 3, 6. So, for example, arrays can have objects of all type. There is a dynamic typing, is dynamic type language. So, and if we press Command E, we open the inspector. That is also another tool, or a useful tool in Pharo, where we can inspect object, okay? So yeah, this array is very simple object. And we can see what we have, the value. We have this number, and we have this character, and we have this string that is also made up of other characters. We go back to the syntax in a while, but then we. Oops. Just you go to the line with the cursor and you press what you want. You press like Command E. Yeah, for example, I should open just one. No, it's just. Yeah. You can select many lines, or you can select just one line, just placing the cursor at the end of the line. Yeah. So this is the inspector, and for example, we can go like Echo Fausto. Maybe you still don't have Fausto with another thing like ordered collection. And if we do Command B, we have, this is called the class browser, Calypso. And in the class browser, we can check how everything is implemented. So the cool thing about Pharo is that it is full reflective. So you can inspect and open everything and check how things are implemented. So yes, you take the course, yes, you read the book, but then you see how things are done by looking at how methods are implemented, especially if they are implemented properly with comments and stuff. We have, for example, an instance side, a class side. If you have any question, don't hesitate to ask me. There is no stupid question. Order collection is a class, and you do Command B, and you go to order collection, and we can see that order collection is in the class definition. Okay, we have the superclass, we have the slots that are instance variables, and then we have a package. We will go to this in a while, to everything. But what we can see is that ordered collection is a subclass of sequenceable collection. We can inspect it, we can browse it, and we see that sequenceable collection is a subclass of collection. And collection is a subclass of object. Everything, the superclass of everything is an object finally. There is also kind of proto-object, but it doesn't interest to us. And then also, one thing we can see. Let's try to do ordered collection open and do Command D. Dot, because at the end, the statement in Pharo are not semicolon terminated, but terminated with dot. Because if I'm just evaluating this, I don't really need it because, it's like I'm evaluating just this line. So it doesn't care. But if I do like this, probably we got another error. Okay. So usually you terminate, but if in this case, simple case, you can omit it. But if we send the message open to order a collection, a debugger is opening. Okay. So we have the debugger inside Pharo. And when something happens, we can go and check what happens. This was just to give you an overview of what comes with the system, because of course learning about all the stuff requires more time. Also, we have, for example, let's go to the class browser. So here on the left side, we have the packages. The packages are like just a group of classes. You define your own packages. These are the core packages of the Pharo language. We have the Coypu, the Coypu package. So a package then can go to a GitHub or GitLab repository. So you create your own classes, you group them in a package, then the package can be pushed to a repo. And you have tags for the different, let's say, categories of the classes in the package. And then you have test. So we have the test. We have this, for example, that is checking my next random integer. And we can run the test. It's very easy to write tests. And a lot of skilled Pharo developers, they do test-driven development. So they write the test is failing, and they write the code inside the class browser and the debugger. So this is kind of advanced technique that maybe we'll see later. But you know that if you like this kind of approach to developing software, this is very easy to achieve with Pharo. As we were saying before, Pharo is used for a lot of stuff, especially like databases, success to databases. There are a lot of companies using Pharo, but there are also like they use graphics interfaces with this new framework block. So there are many things, but before Coypu and Fausto, there was not kind of way to make music with Pharo. Slide. Okay, you already downloaded Pharo, so we got it. So when you download the Pharo launcher, then you download the Pharo, and you decide to download an image, and it also download the virtual machine. It all comes together. And this is the syntax of Pharo. They say all the syntax of Pharo fits on a postcard because we have very few reserved words, okay? And here in this example, there is essentially everything. And there are these important rules on the right. Everything is an object. Every class has a superclass, and everything happens by sending messages. That is what we just saw. Then method lookup follows inheritance chain. So when we send the message, it's looking if it's defined in the class. If it's not defined in the class, it goes up to the superclass. If it's not defined, it goes up to the superclass, up to object that contains 250 methods. So when you subclass object, you already come with 250 methods, like printing and basic stuff. And also classes are objects, and they follow the same rules. So it's a system that is designed is for this that we say is pure object oriented, because actually, like we will see now, also like blocks or temporary closure function like lambdas, they are also objects, they are called blocks. So everything is an object. And then the precedence rules are a little bit different from what we are used to, because first, evaluated are unary messages. Okay, so this kind of message like six. Okay, and if you know unary message first, then binary, and then keyword message. Keyword message is like transcript show. Hello. So this. So this is a keyword message. There's a message with a colon and then an argument. And the semicolon in Pharo is used to cascade message. Okay, so we are sending the message show to the transcript like open. Okay, so now when we have message with the same precedence, the precedence is from left to right. So we could do like it's unexpected, no? Because we expect to be 15, not 18. One you command I to get the inspector. Yeah, so command P is for printing, command I is for inspecting. And then command D to evaluate, command B to browse the class, and Command N to list the implement, to open the implementers list. Okay, so we want which class implement open, what happens here? So, for example, one thing that we use for. So, what is important? We say we don't have this kind of dot syntax that we are used for C-like language, no, that we have been using for all our life. The dot is terminating an expression, a statement, and the semicolon is used to cascade message, so to send messages to the same object. Okay, then we have double quotes for comments, single quotes for string, the $sign for character, array can be created with hash and then between brackets. We can put everything we want. Right. Every kind of object. Those classes. Other arrays, for example. And then to get the element of an array, we have the message at. So is at 2. You know, you were asking before, what if I don't put the dot? If I don't put the dot, the syntax highlighter is working strange because you say what you want to do here. There is not ordered collection is a class, so you want to send the class to the number. Something is not right. So if you, I put, even if you just evaluate one by one, it's better to put the dot so the syntax highlighter works properly. Index after 1, yes. Like in Smalltalk, index after 1, not a 0. So if I say at 0, opla, the debugger opens and say subscript out of bounds. Any number. Any number. Yeah. You can put whatever you want here. There are also like literals array where you can put like also. This is another way to create literal arrays. So we curly brackets, and also we can check at 2 for the correction. Okay, and so for example, now we can just few stuff more. How we do like loops. We can do, okay. First, how we assign variables is very important because now we are just evaluated expression. If we want to okay, so it is column equals, not equals. Equals is to test if two things are equal. There is not the double equal, just the equal, and this will be false. Of course, we are going thing that we know. Okay, and also like if we send a message class to an object, you see, there is no primitive type. There are also like the numbers are instances of, like for example, small integer. We can browse the class small integer, and we can see that is a subclass of large integer and both integer, and then is a subclass of number, and number is a subclass of magnitude. and all it comes with the inheritance stuff, no? And like, for example, you can check here, for example, this is like a virtual method. In Pharo, for today, we don't need to learn about this stuff, but we see that we are not declaring the method virtual, but we are saying in the declaration in the implementation of the method, we are saying that this subclass responsibility. So if I say number plus, I say it must be implemented in the subclass. Okay. So we declare variable like this, and we don't have to declare the type of the variable, but if we are not in the playground, we have to declare the variable first between pipes. This is like if you be checking some of any of the method. Let me see something. No, I don't have anything. Okay, but if we declare inside the method implementation, we have to declare it first between pipes. If we are in the playground, we don't need to, because the playground is a special place and these variables go into the playground bindings. When we declare the array, and there is the bindings of the playground. So the playground is a special place when we declare variables, the variables stay there. And if we open another playground, we can rename the same variable to another object. Okay. So, for example, I want to do dance with open here, and just to show you look. So I have this array, and I can do my array do. And I can say landscape show my scene. Can register. If I do this and I go to the transcript, so this is a for loop. You send a message do to a collection, and the argument is a block. This between square bracket is a block, where there is the local variable that we know all our life. No? And if we evaluate just pieces of code, we can, like, I can take this block and send a message class and do command P, and it tells me that is a clean block closure. So evaluating pieces of code, I can do stuff happen differently for what is the statement itself. In the comments is how things are implemented. Yeah, we're just looking at how we do a for loop. You send with message to a collection. Or, for example, you can do collection. We can do like this very simple stuff. We can do 1 to 8. This will be an interval. We can always send a message class, interval class. And we can do 1 to 8, collect also a block in. So, okay, very stupid. E plus E times 2. Let's assign to a variable. So you can create an array from intervals with the message per length. There are very few basic messages that you need to learn, and then you can learn. Like, for example, we can see another classic example. You can see where you go to AC25, and we send the message as uppercase. And for example, strings are collection too, so we can ask at 5. We can check what happens with the block that plus 2. So a block is only evaluated when we send a message value to it. Otherwise, it stays there and is waiting to be evaluated. So if I do Command P, the block, I have to exit value. All right, click plus V. So block can have and also. So you send the message value, just value, you already know that the block has no value. If you do value, and you can give it a value when you have declared a value. And I think that can be enough for now with the Pharo syntax. Any question? Everything clear? Is everything new? So, now we install Coypu with Fausto. To install, there is this script. It is on the repo. You can copy this, or you can copy it from the repo. Command D on Mac, Control D on, and you have to select everything if you put it carriage return like this. Now it will probably take some time. So if we go to the repo, we have the repo here. We copy the code. Yeah, code. Well, this is a little code. Yeah, you can copy that and you open it. Let's open a new program. Let's close this. Let's close everything. There are a lot of windows. Some people hate the window style. It's very like 90 stuff. Some people love it, so it depends. It's a little bit of love and hate for various about this window system. That you open a lot of windows, you have a lot of windows here, so it's like a mini OS. By loading or by offering the playground, they don't have global. So this thing is called a metachannel script. The metachannel is taking care of all the dependencies. So it's going to the repo, taking the correct branch, and following a baseline and loading to your system. What is happening is that everybody was able to do it. No problem. Fantastic. So now what we would have to do is do save. Pharo here, save is also shift, shift command S.
Where did it say?
It saves in the image.
Ah,
Yeah, you have the image, and the image, then you can give it to your friend, and it will come. That's why I had also the image in a USB stick, just in case if anything happens. Yeah, but if you do if you evaluate the script and then you close the image without saving, you won't have it. So everything you do and you're not saving is lost. No, it's of course this also means that the more repositories you're loading, the more repository you will find in your class browser. So the more your image will grow. That is something also somebody can like it, somebody cannot. Because I don't want to have so big thing on my drive. Okay, so let's check where we. You should type. I try to type echo Fausto start. And if it was loaded properly, when you evaluate, we should hear a sound. Like this. Right?
say it started once.
So first, when you type Echo Fausto, you should have the tip for Echo Fausto. So the Echo Fausto should come like in bold if it's loaded in your system. Otherwise, it's not. So a little anatomy of Coypu. We say that it is domain-specific dialect. Okay, so it's a subset of Pharo, superset of Pharo to do music, to program music on the fly. So as we said before, Coypu is a kind of score. It's acting as a score. You write the music, but you need something to perform. You need an audio server. That can be another program running, communicating via open sound control. I guess everybody knows. So you can connect it to Max, Pure Data, Chuck, SuperCollider, whatever you want. You can connect it to a MIDI synthesizer or to a MIDI virtual driver. The ADC Mac in Windows is a little bit more complicated. So you could even play Ableton Live if you want. And you can create, transform, manipulate rhythms. So we will see all the stuff that there is inside Coypu. And then you can also create custom OSC controller. What we have a performance. We have to think a performance. Now we see in a bit. A performance is a singleton. So it means that, are you familiar with the singleton design pattern? Nice. So there is only one performance. This is because we wanted to have access directly to put the sequencer, so the tracks, let's say, directly to the performance. And then we have double dispatch mechanism, and there is the performer. When we send a message play, the play goes to a subclass of the performer. So we create a performance, the performance needs a performer, and then the performers, when you send the message play to the performance, it selects the performer. You have performer local for open sound control. You have performer MIDI for MIDI. You have Fausto. This Echo Fausto is a special version of Fausto. There is Echo Fausto and Turbo Fausto. Then you have Kiva, if you are lucky enough to have a Kiva hardware, that is kind of expensive. And SuperDirt, if you want to play SuperDirt audio engine as title cycle, so you can start SuperDirt. There is the example on the Fausto repo. Very easy. So here we can see the performance is like, let's say that is when we open a digital audio workstation, it will be the performance. Okay, so we have different tracks that here are called sequencers. A sequencer can have different length. So a sequencer can be 16 steps, 32 steps, 8 steps, 64 steps, 128 steps, whatever. Every sequencer has a key that identifies when we call it. Okay. And inside the sequencer, there is a lot of data. This data, the essential data is gate. So if a note is playing or not, 1 or 0, okay. The note in MIDI number, so 60 for the C, and so on. You have a duration. Then dirt message if you want to play the super dirt. Okay. We don't care for the moment, but if you check on the example, it's really easy and fun to play super dirt. Also, the data inside the sequencer can have different length. So you can have a length for the gates, a length for the notes, a length for the duration, and you can do very complicated polymetric stuff between sequencer and inside the sequencer itself. At the moment, it's running in 16th subdivision. So you cannot do 32nd subdivision or 64th, or you cannot do triplets. We have to do it in the future, is on the plan. Now it's all in 16 because basically I do very repetitive techno music. So it was, I need it. It's translated to my word. Also, the pattern not cyclical like in time cycles or strudel, but are linear. So it's very easy to concatenate longer sequences, but not to do cyclical polyrhythm. A few stuff before we go to do some noise. The principles with which I designed Coypu was iconicity. So the written code should resemble what we hear. Okay, because for me, many languages for programming music on the fly, they're really cool, but they are very obscure. So if somebody is coming and is not somebody that is using the language, he doesn't understand anything. With Coypu, you can understand. And then there is also this principle of economy where the less we type, the better, because we are performing when we don't want to have like, okay, we have to follow the principles of Pharo that we want to do ourselves. So, for example, I implemented this message that sum a number to all the elements of a collection. So that is 60, 63, 67 is like a minor chord of C, and you can sum 16 semitones like that. Is it kind of violating a little bit the rules of Pharo. And then also polyphony, more than polyphony, I will see synonymy. So there are many ways to do the same thing, and you decide which one you like best. If you want to type more or if you want to type less. So we would say that Coypu is unopinionated. You can do stuff very different way. When we create rhythms, everything is thought like in time unit box systems. I don't know if you ever heard about time unit box systems. So it's just like iron squares where you have a square, that is a grid with steps and rhythmical subdivision, and you can use it like an X or black and white. And the X is plain, the white is not plain. And then you see the gray, you have an extended duration. So you see here the different way, the time unit box system, the traditional score, and as you can write it in Coypu, this is the most simple. You send a message as sec to a array of 1 and 0. Okay. Now we'll do noise a little bit more. So here you see the very simple, essential example. We assign to the variable the performance. We send a message unique instance because we say this is a singleton. This is not so transparent, but I like to keep it like that. And then we assign a performer. In this case, was a local performer. Then we decide a speed, and then we create this sequencer with 1 and 0. We send the message as set, then we decide the notes, and then we assign to the bass track, okay? And then we play. Okay, now we can go and have fun. That is better than talk. Okay, so let's start. Everybody can do Echo Fausto start. We will see later what is Fausto. We know that for the moment I tell you that inside Fausto put a little Faust compiler. Are you familiar with Faust, the programming language, the functional programming language, Faust, or DSP programmer? This language that is also developed in Lyon, in France, by people of Grand now area, and is very full language for DSP programming with an extended standard library, but kind of difficult to use because it's functional, so it's kind of cryptic. So Fausto puts the Faust compiler inside Pharo that you can use for sound and to play back samples. Okay, so Echo Fausto starts all the sounds that comes with a lot of sound that comes with Fausto. There are two versions, Echo Fausto and Turbo Fausto. Echo Fausto is done for slower computers, and Turbo Fausto is done for faster computers. You guys see in your computers it's all for Turbo Fausto, but for educational purpose it was done like that. So then we create an instance of Echo Fausto. So we call it whatever, I call it just AP. You can call it whatever you want. So there is a little abstraction. So everything that is done, everything that it was in the example, this Echo Fausto is doing it for you. So it's creating a performance, assigning the performance to the performance. Okay? And we can check which instrument we have on Echo Fausto by sending the message list all instruments. So what is happening here? If you open the inspector, so sending the list all instrument, okay. These on the right are all the instruments that come with, all the instruments that come with Echo Fausto. So we have key, snare, CH for close hats, OH for open hat, cowbell, conga, bongo, blip, speak span. So what we have to do, we have to create a sequencer, and with the two message, we create a sequencer that we assign the sequencer into the performance. So if we just send a message as sec, you can inspect it, and there is all this information. But we just created the sequencer. We didn't put it into the performance. To put it into the performance, we need two. Okay? Two, and then this thing in Pharo is a symbol, is a unique string. So in Pharo there are symbols. They are just preceded by hash. They are a unique string. And so when you send a message to, you say, okay, I create in the performance, I put a sequencer called kick, and it will play the kick instrument of Fausto. So this was made to have quick fun. So you can try to type this, and then we can try a P play for 8 bars. Right. change it in real time. So if you go to the repo of the workshop, there is this Coypu business card. And you can copy it and paste it in your playground. And if you copy and paste it onto your playground, you will have all the performance I did at the beginning. We will see later that we can create kind of our own Fausto, Turbo Fausto, custom Fausto thing to put our instrument. This was done for workshop and for educational purpose. And the thing is that you always have, you will have to adhere to a syntax when you create the instrument, but of course you have just one kick. If you want two kick drum, you should have the other one called kick two or kick big or kick small. And so every key for a sequencer is unique. And you say, okay, you say that there is kick, you mean that some instrument has this kick gain parameter. We say later. You see later. So I'm going to play. You play the snare, we play the snare. But if you put another thing to the snare, it's changing in real time. So you can try here, for example, with the kick and start. But I can change. For example, I can say planar adds rhythm. I can say rumba. Or I can ask for rambo tricks. And then again, you linear beat. And in the message linear, not missing anything. Then if I cascade notes message, I change the notes, say, augment the string. Default. What's like default? 60. 60 like C4, middle C. So if you don't say anything, it's like note is 60 and the duration is like the number of gates, the length of the pattern divided by the number of gates. So like if you're down beats, every 3 plus 4 steps. If you have 8, every plus 2 steps, and so on. If you have 1, you have 16 steps. So, the tempo you decide with AP BPM. The standard is 146, but we can make it. Leads, we inspect it. We have all the rhythm that we got inside. Right. Listen. few words. This Turbo Echo Fausto was done for workshops for educational reason, and it was inspired by Super Dirt and Super Collider. So you have a lot of samples that it comes with that come with this in this folder, Turbo Samples folder. Part of me are made by me and with my colleague at the Analog Cops. Also, a lot of samples come by the Dutch electro producer Legovelt. I don't know if you know Legovelt. Very good. And it puts a lot of samples. So if you go to the Turbo Samples folder, you see that inside every folder there are many samples. This is because now we see we can play the sampler as multi-sampler. So, for example, okay. So we saw that we can just send the message back.
Can I ask you that question? I don't, I nearly get the reading box, I remove some CPU box.
Okay.
Already. Because if I remove two zeros, it should be equal.
Yeah.
I expected to see equal less. But when I listen to the partner,
Yeah.
it seems like only 16. So if the measure it.
He's always repeating because you asked to play it for 2 bars, so he's playing 2 bars of 16. Anyway.
Yeah, but the manager does last 160, 16 more than I expect.
Ah,
I don't know if it, maybe I didn't get it.
we have to check. Later we check.
But listening, I'm a bit sure that it's a result. But maybe that's I don't.
Let's see. Let's see.
Yeah, I have 16 numbers. Then I do 2, but with our left only one something. Influence will need a good only. Yeah, no,
So we have this sample folder. Speak span. But so we can change like let's write something shorter. I don't know. Waivers. Okay. Waivers, we send a message as reader to speak and span and okay. So we say we can cascade the notes message. So the notes message we can put 60, 43. Now then we see his syntax. Or we can select the index we play. So the number of of the sample in the folder in alphabetical order. So if we put one, the message is index. Okay, so we have these. All these are samplers. The first one of the list, and then we have two synths. We will see the synths in a while, and we can send the message notes, and we change the notes. We can change the index, so the sample that is going to be played, and we can change also the duration. But of course, these are percussion, so we don't need it too much. Okay. So these are, for example, two ways of creating the rhythms. We can send the name of the rhythm to a number of steps. Say, okay, I want a sequencer that is long 16 steps with quavers. Or you can send the message as rhythm to a symbol that is one list, a rhythm of the list that you get with rhythm list inspect. And you get 16 steps of that. So this is kind of shortcut. Okay. And there are two exceptions that are breves and semi-breves. So you ask for 4 breves or for 8 semi-breves, but it's not 16. This is something that I would like to change, but at the moment it's like that. So this is another example of saying the same thing, and we will talk in a bit about X-bit. Have you ever heard about X-bits? So X-bit is a way to create rhythms with hexadecimal symbols. So it became popular with in the live coding scene. There is a link where everything is explained in detail. And you have to think that every X symbol, if you translate it to binary, you get 4 steps. That is perfect for us that we are reasoning in this 16 technical way. So 0 is 0, no 3, easy. 1 puts the trig at the end of the 4 steps. 8 puts it at the beginning to 8 in binary is 1, 0, 0. And if you, for example, you got F is 1, 1, 1. So easier to listen. So if we evaluate another time echo Phausto new, we create a new instance in that variable. So everything that you written before, it disappears and we can start again. Or you can send the message mute all. Okay. And now we can try with our XD. So for example, that's why 8, 0, 0, X beat. 2, 4. I put 8, 8, 8. And I put 8, 8 at. So we can create very long sequences with very few symbols. Of course, some symbol is more easy to understand and to memorize than other, but after a while that you say, okay, I want to create a typical garage pattern, so it's like 9090 E. Solo. Solo. Like no, it's not. So we see before how we can create Euclidean rhythm. I don't know if you have ever heard about the Euclidean rhythm. There is this beautiful book about, written by Godfrey Croissant. He was an ethnomusicologist, Canadian ethnomusicologist, that was studying the distribution of how what makes a good rhythm and how these good rhythms are distributed even across a pulse space. So you have 16 you have 16 steps and you distribute 5 tricks. And if you divide the space with an Euclidean algorithm like the Bjorklund algorithm, what you have kind of always a good rhythm, and you discover that many of the rhythm, folk rhythm of the world, like tresillo, rumba, banda, and all of them, they are Euclidean rhythm also. So when I was compiling the rhythm for Coypu, I was reading the book, getting the time unit box notation of the rhythms and writing inside the write. We saw that we can send notes, duration, and gate times. And then there is also the last thing that we do a little break. We can send this message as dirt nodes or as dirt index. And we have tokens separated by comma, where a tilde is a break, and we can repeat the same step or elongate the step. It's easier again to see that. So let's see that I can have like 60, 63, 67, and a tilde as their notes to speak style. And the same can be done with index. So I can say, I want do, and I want wait, post step, I want this, alright, wait, click on, 118, okay, as the index. So this is a way to create like this masking notation. There is like a string notation that is really similar to the one used with tidal cycle. So with tidal cycle, you can write patterns in the same way. You don't need to put it separated by a comma, but you write like the number and note, and you repeat, and you have the tilde for a break, for a rest. So the idea was if somebody is familiar with tidal cycle, he will be familiar with this syntax too, or otherwise you can learn this syntax and then use tidal cycle if you want something more complicated. You can do a little break.
Can we change the power column if we find like now I think it's 4x4.
Yeah.
Can we change that?
If you want to, you can change that, but you have to know a little bit of Pharo and to go inside. So, look, this was a good question. Of course, now you don't only have Pharo to change it, okay? If you study 3 weeks, maybe 2, you're good. But you go inside, okay? You go to display format. You highlight, you press Command or Control M, and you have all these methods where they are implemented. Now I have a lot of zoom, so this kind of. But in the performer Fausto, what is this? Okay, you go inside here and you see there is like, the architecture is like you have the performance, you have a transport step that is incremented every time. Okay, so now all the sequencer can have different length, but not different time sync. So if you want, you can change that, maintain the same architecture, but make it play different. It's something that I should do because it's something that is needed. I was doing the stuff a little bit step by step and for what I was needed, but everything you can go inside. For example, you can go inside XBit. There is just one implementer at XBit, and you can see how it is implemented. If you look, this method is not so obscure. No? Command B is for an object or a class. Command M is for a method, for a message. So you go, you highlight the message, you press Command M, and then you get a list of all the messages that are implemented. In this case, the X bit is implemented in the byte string class. You can, of course, Coypu is done by, doing a lot of extensions. You can do extension. So one of the cool things of Pharo is that, okay, I want to add a method to the integer class or to the byte string class, and you just go there and you write your method and you save it in your package and it's done. With other languages, is a little bit more complicated. No? You can do overload and stuff like that, but it is a little bit more complicated. So the cool thing of Pharo is that essentially, if you look inside Pharo, you don't even need the manual at the point, because you can check how it's been. So going back to slides, we have seen how we can construct the rhythm with this as rhythm. We have also way to create random rhythm. So we have random rhythm. Random rhythm makes 16 steps of a random rhythm in the list. So you don't know what you get. A random trig is just random, 16 steps of random. And then you can have random trigs with probability. So you can have more probability or less with this random trig with probability. And then you can also ask for random notes in a scale or random notes from an array. So you can say, okay, I want 24 tricks of playing, and then I want random notes in this scale. There are many scale defined. Now we'll see in a bit also the scale how it's defined. And or you can ask for random notes in an array of notes that you just defined. Everything we are doing here is like very extended, very verbose. But of course, you can create your performance by declaring the variables step by step. So you can say base notes and you give the array, then base trick and you decide the tricks and then you combine. And maybe it's easier to build like that. This is like boom. So it's in your face. When you perform it, could be maybe faster, but is then a little bit more difficult to articulate. So the initial idea is that you can use Coypu to do live coding at an algorithm, but you can think about Coypu also to do music in your studio. So it doesn't have to be performance like it can be like a composition. So you take your time and you say like first part and you define all the patterns for the first part. Then you combine it with second part and then break and you make longer composition. Also, there is a Markov jazz melody generator with a very simple Markov chain, and you decide the root note and the scale, and gives you some effect. And we will try it.
I will be chain. Oh, it's the opposite section.
You can combine. This is the sequencer operations. So you can combine sequencer with comma. That is how comma is that arrays are combined in Pharo or collection in general with comma. So you have an array, and with comma you have the extension of all of that, the combination of all of that. Same here. You have jungle kick as rhythm, you combine it with the downbeats as rhythm, and you combine it with AAF X beats. Okay. So this is operation number one. So you can define first part and can be a combination of many rhythms. Then you can have second part, and then you do first part, comma, second part. So declaring more variable, doing things more like step by step, then you can articulate the things more complex than just throwing a very long string or X beat. Then you have also this operation with the times. If you say times, it repeats the sequence. So you can do repeat and then combine with another one. You can repeat this AAF 3 times and then give a downbeat and then give some rests and combine more. And then you have a plus that is a simple transposition. So it takes all the notes and is pushing up or down. You have plus, I mean, you have all 7 semitones. This is really like, it's for performance, but it's still something that can go with more articulation. So you have this class that is called scale. Now we take a look. And if you send the name of a scale to the scale class, you get this return is what you get when you send a message. You get an array of the intervals. So 0, 1, 5, 7, 8. Of course, this is kind of useless if you don't give it a root node, because in MIDI, note 0 or 5 or 7, they are too low. So you can, for example, send plus to the scale and you sum the base note, or you can define with this keyword message, root octave, you can decide a root and then you can spread it on 2 octaves. So you have different way of combining things and scales. So if we go back Pharo, we can go scale, common B. We can go to the class side, and we have all the scale: augmented, bebop, blues, enigmatic, flamenco. We have quite a few. And of course, you can. It's very easy to implement the scale, because if you want to Domenico, and I say that it is and I just save it. And then I can send the message scale Domenico, and it gives that. So it's very easy to implement methods in Pharo. Is really easy because to do stuff that are more complicated or that are more simple or to group variation, it's very easy. Then of course you have to save the image, and still it will stay in your image. But if you break your image, that can happen. You lose the change you made in your code. So usually what we do, this is already in my package, but you can define your package, and of course you can do like a fork of Coypu, okay? Or you can do your super Coypu. You create a package, and once you go to the, we have the package here is Coypu, and Coypu there, many more. But once I have done a chain, I can go to the Git repository browser, also known as Iceberg. These are my package that I modified, and you see uncommitted change to Coypu. So I commit, and I say example method for ADC workshop, okay? And I commit. It's also running some kind of checking the sanity of the method. So if I would have something bad, it would say, you cannot do this or you cannot do that. Take care of how you're combining methods or stuff like that. And then you push. And it's easy like that. So it's very easy to keep the stuff in your repository once you have defined your own repository. So there is something that they tell me to a piece of housekeeping, that the venue team will now be transforming the conference space ready for the evening activities, including the ADC quiz. And therefore, the main Bristol suite will be unavailable. Please use the next 90 minutes after the workshop. The bar in the Empire lobby outside this room and another bar in the registration area are now open and serving alcoholic and soft drink. Please also use the main hotel bar area, which is up the stairs, either via the conservatory or the main hotel lobby. Please refer to the venue maps you were given at registration or ask to volunteer. The juice team will be hanging out in the hotel bar talking all things juice and happy to take questions and discuss juice-related issues. In general, please make use of the full space available. An evening meal will be served in the Bristol suite from 6:30, and ADC quiz will start around 7 p.m. This is just for later. Okay. All clear about Coypu? A lot of stuff, but you can basically go to that postcard, and in the postcard, in the business card of Coypu, and there is all you need to know. Then you don't need to know all Pharo to use Coypu, but of course, the more you know about Pharo, the more you can modify and custom define your method and do more stuff like you were asking for. How I do my stuff? Yes. Probably you do your Coypu better than mine. That's not better, but different. But you need to know something about it. But to start, you just need to have Echo Fausto, Turbo Fausto with a sample, and you can have fun. You can, of course, change your samples, because every folder, you put another folder in your Turbo sample, and you call it like, I don't know, flamenco guitar, and you have your flamenco guitar. Just samples. But you have also synthesizers. So the synthesizers are done with Phausto. Okay? And Phausto is, we said before, a library and API for sound generation and DSP programming inside the Pharo IDE. And this thanks to an embedded Faust compiler. So when you run that meta-child script before, when you are installing Coypu, you are actually installing Coypu and Phausto. And Fausto is also downloading a dynamic library, a C dynamic library. C dynamic library. It's putting that next to your Pharo image. So Pharo can use C library, can you make FFI to C library. So we are communicated to the Faust compiler that is running inside. This is how we can do sound inside Pharo. And Fausto is a kind of modular synth inspired. So the idea is you have a lot of unit generators and you connect unit generators, setting their members. And we see how it means, what it means, or using the chuck operator. We like a lot the chuck language. So we borrow the chuck operator that is equal greater than. And when you can chuck an oscillator to an envelope and chuck it to a filter, chuck it to a reverb, and it goes to the output. So today I wanted to give you an overview of these three different stuff that is Coypu, Fausto, and maybe a little bit of block at the end if you have time, to show you what you can do with Pharo in terms of music. So maybe you want to use Coypu, like we said before, and you want to use it with Super Dirt. You say, I don't care about Fausto, I use it with Super Dirt, or I use it with my MIDI synths, or with Ableton, like whatever. Or also you can say, I don't care about Coypu, I don't want to program music on the fly, I just want to prototype my synthesizer. And it's a good way to prototype the synthesizers because it's easier than use Faust. You're not familiar really with Faust. So Faust is a functional language, very powerful, but being functional, the syntax is some kind of obscure sometimes. And also when you define the UI, it becomes very verbose, okay? So if you want, you can try to copy and paste, to copy this little program. You can open a new playground if you want or no. Yeah, there is some. Yeah. Thank you. Mm. Let's try around the street now. Let's try without the filter. Because the filter is closed by default and it's simpler without the filter. So let's forget the filter. Good. The trace of arms can go here. Now we explain what it is. So we remove the filter.
What are the essential things we're doing?
Yes. Sometimes, especially with Faust, it could be dangerous because if the so what is happening? You create the unit generators are Pharo objects. Then you combine them with the chuck operator in this example. Then you say, okay, I have this synth. This synth only exists in the Pharo world. And you send a message as DSP. When it's becoming as DSP, it becomes a pointer to extract in the C world. And so if something happens before it should happen, it would crash. This is something, it's a little bit, this is something that has to be modified. It's a little bit it is for the Faust. Faust is written in C++, the dynamic engine. So we are making like wrapping into a C extern, and then, but when we have try catch in C++, then it blows up in the FFI. So better line by line. But of course, if you have a script that is not this kind of problem, you can do it. But for Faust, it's better line by line.
So you can do it straight time, also like we don't know by
Yes, when it's everything in the farm world, it can go because you say, okay, do this and that, and because maybe something is happening a little bit before, because it's not taking the same time as a process.
line by line.
Yes, it can compile, but imagine that you're building a complex object. It may take more time than evaluating the second and the third statement. That's the point. It's the order is respected, but the time of the result may be different. Okay, so this example, everything had it working. Yep. So it's just an example of connecting unit generators. Unit generators is things that produce signal. So in Faust, they are function because it's functional language object doesn't exist. Here in Coypu, in Fausto, I decided to call it unit generators, like they are calling traditional music N. I've heard about music N, probably the first computer language made by Max Matthews, that gives the name to Max MSP. So in the first implementation of a program of music and type of language, unit generators are everything that creates sounds or that process sound. So I maintain the same definition for these things that in Faust, they are function. So we can, for example, if we open we can open the class browser with command OB and go to Fausto in the package, and we can see what we got here. For example, we can go to effects, and we have a list of the effects that we have. We can go to envelopes, and we have a lot of envelopes. In the comment, it's explained the parameters that you have and which kind of envelope, This is released to final value. There are logarithmic, exponential, attack release. And then, for example, you have a lot of noises. You have colored noise, pink noise, sparse noise. You have a lot of Casio CZ type oscillators, LFOs, the classic pulse, square, sine. And then you have seen the effects that you have physical model, you have a lot of stuff. Now it's just like showing you what you got. But the best thing, so you connect the unit generators and then you send a message as DSP, and as DSP made the magic and made a DSP, a Faust DSP. It's actually Faust DSP. Then this Faust as DSP, if you send the message stereo, it makes a stereo, because in Faust everything is mono if you don't decide it's stereo. Then you initialize the DSP. When you initialize the DSP, you say, okay, in the background, you select the audio driver, you select the buffer size, and it's all done behind the scene. If you go to the init, you do command M, and you see a lot of stuff happening here. That is basically the FFI initializing the DSP, and then starts is actually computing the values that then are given to the audio buffer. So DSP, you combine the image generator, then as DSP, made a DSP. The DSP is not connected to the sound interface until you say init, then you start. And when you start, you hear the sound. And this play note is like behind the scene how it works when you are using Coypu. It's just calling this play note all the time, calling with, instead of the prefix my synth, is prefix kick, prefix snare, prefix conga, because all the synthesizer and samples are organized in a way to be coherent with that syntax. And it was, I hope we will have time to do it. But when you construct a synth, you just say, okay, I need a certain type of parameters, and it will work for Coypu. So if you want to work with Coypu, so with this play note stuff, it needs to have a parameter that is ending with gate, with trigger, and one that is ending with frec. It's written on the slide. We will check. So he was trying to put a pink noise, but the pink noise gives some kind of problem, because the pink noise itself, it doesn't have a frequency parameter. Okay, and so you say, okay, I got the trigger inside the envelope, but I don't have the frequency, so you have to invent yourself. Maybe you can put a filter and map the frequency of the filter to the, that could be an option, you know. So this is how it works to play a note, but we can create things and play it also in other way. If we want to learn, we will take a little bit of time now. We have time to, if you evaluate master loop go, master loop go. You send a message go to master loop. And master loop is a tutorial that is made in the fashion of Prof. Steph. If you want to learn, there is also Prof. Steph. Go. And you can learn Pharo with Prof. Steph. Yes, we have to download. Sorry, my fault. Very good. Okay. This is the script, master loop. You see the script? Metacello, new, baseline. Yeah, because there is also Prof. Steph. Prof. Steph, if you say Prof. Steph go, you can learn Pharo with Prof. Steph in the same way. It's kind of interactive tutorial. So master loop is a subclass of Prof. Steph. Working? No. No, we can take a look in a meanwhile what is happening. Okay, because we have Prof. Steph, just to see that you can learn still stuff. Not today, like send the message late today. Now to time. Next. float, message pi to float, all the stuff we've done in the first part of the workshop. But this is example. If master is not going, you can just copy for the we wait, but then you can just take a look at this. This is like the hello world. So to create a sine oscillator new as DSP, you initialize and you stop. That's hello world. We want to change it to square. We call it sine oscillator. Okay, we want noise. Okay. Go to the next lesson. We say that you need a stereo message, you have stereo. Okay. Then, fourth thing. We create so we say we have these unit generators. We initialize the unit generators, we combine them, then we create a DSP. The DSP is initialized, is started, but then we want to interact somehow with this unit generator. So what? We have to send to the DSP the message, the keyword message, set value, a number, parameter, the string with the parameter. How do I know the name of the parameters? I send a message, trace all params to DSP, and so on. So if somebody has used Faust, the difference is that in Faust, you have to create a UI element, like a slider or a button for every parameter you want to control. In Fausto is created for yourself by default. So every unit generator has always UI controls. That means that you can control it in real time. So we can start it again. Yes, you can do it. Let's do it like that. I can say, pulse one, okay. Pulse two, push, new. There's another. And I say that the DSP is pulse one plus pulse two. I have to be careful and to use parentheses because otherwise unary message first in Pharo we say, so it will be pulse one unit generator in Pharo plus pulse two as DSP. So it will try to sum a unit generator with DSP, probably it will crash or it will curse me. So you have, you say, okay, first this between parentheses, it becomes as DSP. So plus is just summing. So in Fausto, if you want, that would be like lesson 7, I think. If you want to something in a mixer, you just plus, and you have a lot of unit generator. And you initialize DSP, you if you don't define your label like we were doing before, label my synth, you say, okay, I call it with the name of the class. If it's just one, it's just pulse os. You make the second, okay, it will be pulse os 2. You make the third, pulse os 3, and so on. So in this way, if you don't want to name thing, you know that this is the convention. So now if we want to change, change it quickly. So it's very kind of easy to combine stuff because then, for example, we could have like an envelope. New, no, and we chuck this into the end. So if you chuck this in the operator, in the envelope, we start. We don't hear any sound, of course, because there is an envelope. The envelope must be triggered. So I go here and I say trace of params. ADSR M2. Now it's to start again. This is a little bug, but so I have to make DSP to trigger an envelope, set value 1 parameter. Let me copy. Trigger is oh. Okay. And if I don't we play for others because I'm sending message 1 to the trigger, so I'm triggering the envelope. And if I don't send the value 0, it's just staying like that. But this was a little bug because we didn't stop the DSP, so it should be 1 without suffix. Yeah. Because if you don't, when you send the message stop to the DSP, you say, okay, when you create a new DSP, I'm starting counting from 0 again. Otherwise, I'm counting from where you left it. It's a little bit, you left it dirt, and I'm saying like, so that's to say other stuff. The reason why master rule is 15 lesson of is just text. It's taking a lot of time because it's coming with Coypu either. That is what we will see in the last part. And so is the Coypu either, we can Gembe started. And when we send the display UI message, we got an UI. Of course, you can still set your values like before manually, because at the end the UI is just calling that method, so just sending that message, nothing before. So just to see the noise. We have many models like electric guitar. And here we can see like that. So I'm creating a gem. I give it the name electric guitar because it was before, but I need a frag and trigger parameter. So then I connect to a DSP, initialize, and start. And here is how you can create this is a Pharo process. So a Pharo process is just something that is repeated inside the block and called with a delay. So you call the delay, and it's just sending the value again and again. Okay. This is, of course, the many way that you can have to play Fausto. Because I said before, you can play Fausto without Coypu. You can do like low level processes. This is a process. So a process is just play a random note and to this prefix that is wrong, and I give you a duration, and then wait 125 milliseconds before triggering the next notes. And then I repeat 128 times repeat pattern. This create a process inside Pharo. This is the Pharo process. And 4 is like for, let's say, multi-threading in Pharo. So I say, okay, start this process with a low priority and make it go. So in a way, you can create your own sequencer using processes. And this is how Coypu is implemented. So Coypu is just this transport step we were talking before. It's just a process that has a very high priority, is incrementing every time little step, like at 120 BPM is incrementing every 125 milliseconds. And it's going and it's going and it's going. And this is how it's implemented. So if you then have a better internet connection, you should be able to download master loop and to check what you can do. So the idea is that if your naming convention is you have a freq and a trigger parameter, you can make the synths that are used to be played by Coypu. Also, you can create a DSP yourself. Like this is an example you can try later of using just instruments. The Faust standard library can also be some instrument like a kick, synthesizer kick, a clap, a comb string, a kind of trombone, and you can sound them, and they will all have the freq and trigger parameters, so you can play. So you can create a DSP, just custom DSP, to make it work at the moment, and initialize it and play. Of course, this will be something that will be very volatile because you close, and of course, if you save, when you save the Pharo image, if we now save and we close it, it's asking for also for saving when you close. Hello. Okay. It's starting where we left. So the playground is safe. And also the playground, if we open a new playground and we go to pages, we can load what we've written before. So it remembers what you were doing. You know, all the different pages are opening different playgrounds. So in 1 month, you could get back to what you were writing today and say, okay, what was I doing? Okay, I was doing this performance here. And this performance there. So the basic thing you can is just ask for a new synth. If it is a synthesizer, if it is in this, we open Fausto. Fausto as a tag that is called Turbo Fausto, and inside Turbo Fausto there are these TP synths or subclasses. These subclasses are made for be played by Turbo Fausto, so they always have a trigger and a gate and a freq parameter. So you know that this can be played with. Faust with Coypu, because all the things in Turbo Fausto are made to be played with Coypu. And the idea is that you can check how it's done, and you can try to do your own. So the idea now, we will take a look also to how it's implemented to Turbo Fausto. Was it all clear till now? A lot of things because we said at the beginning, it is going to be a lot of things, but it's going to show you all you can do, because you could do like a workshop just for Fausto, just doing Coypu, or just for fun. But the idea is to have a little bit of everything to see if this can be interesting for you and what you can do. Also, I will be tomorrow with a little poster, and we were explaining more about Fausto. And with Fausto, you can implement your DSP, and you say, why I'm doing this? Yeah, to make sound with fun. Okay, to use it in a performance of Coypu. Cool. But also you can export it at the C major patch. So you have DSP, you export the C major patch, and you get the C major patch, and then you can load it in the C major plugin loader, and you have BST ready. Kind of easy way of building it, or prototyping. And also you can export to plain C++, like for if you want to put it on a Bela or on a Teensy. So it's a good prototyping tool, especially if you want to build higher level stuff, because if you want to implement your own reverb, maybe it's not the best to implement your own reverb from scratch. Maybe Faust is having more recursive feature. It maybe it's better. But if you want, like, I don't know, combine a reverb into a filter and then into a delay and something like 2 oscillator like before, or 3 or 4 or 5. So we can take a little look of how to Fausto. So again, we have in our package, we have Turbo Fausto. This is a class used to load all the instruments. We see the method. There are the method on the class side. Okay. I can start to investigate how it's done. I can go, okay, what is start doing? Okay, it's creating a performance, is initializing a performance that is a unique instant, is loading all the samplers, is loading all the synths, is loading the filters, and it's for Turbo Fausto. What is load all synths doing? Okay. It's creating an ordered collection. An ordered collection is like an array that doesn't have a fixed size. So I can create whatever I want. And I'm adding to this ordered collection a djembe. And this djembe has a label called djembe, and there's a parameter called djembe trigger and a parameter called djembe frag. So that's what it needs to be played by Coypu. Every instrument you play, you implement, needs to have a trigger and a frag parameter in camel case, because it's how it's written. Of course, you can decide that you can create your own version of Coypu, and you don't need to be camel case, or you don't want to call it frag, you want to call it mode, or you want to be everything uppercase. The thing is a little bit tricky, because either way you have to remember. So when you call it, you have to remember. But all the time you go to you should be like consistent in a way. You say, okay, I start to implement my custom Fausto, and I'm doing everything with uppercase at the beginning, or everything with lowercase at the beginning. So if we want, this is Turbo Fausto, so Turbo Fausto is more complex. But if we want to do Echo Fausto, what is Echo Fausto doing? It is a subclass of custom Fausto. So when I send a message start to Echo Fausto class, is is not implemented here. So it's looking in its superclass. When it's looking in the superclass, okay, let's go to custom Fausto. Custom Fausto is starting. What is doing when it starts? Okay, it's initializing a performance, storing into a variable, and then is trying to stop the DSP if it's not existing. This is some kind of low level stuff. And then it's loading all the instrument. So, okay, load all the instrument. This is virtual function. Is set subclass responsible. So, okay. I have to go to here. I can double click and open full screen. What is doing here, load all instrument, is initializing all this sampler, okay? And it's adding all instrument variable, all these instruments, okay? So if you want to implement your own version, you can add, like, for example, here I could add, I don't know, Uber. Let's say TP Uber new label Uber. Here you have, no, we were saying before, we have to declare variables. If we declare variables, we need to put it between pipes. We don't need to do this in the playground, but we need to do this in the method definition. So in the message definition, we have to put it. So, okay. When I try to save, we say, hey, Uber is an unknown variable. What you want to do? Declare it as a temporary variable, declare it as an instance variable. Temporary variable because it is only here. And this you need to know a little bit more of Pharo. And then also I have to add it to this ordered collection. So I say also Uber here. And now I should also add Uber. So also say I could also start. So now it will say Phausto so instance of Phausto didn't understand. Okay, so I have to ask for the DSP, the DSP side, and here I have all the instruments and all of the parameters. And now you have also at the top, at the bottom of the list, we have this TP Uber, track and trigger. So I know that I can play this now. Should. So again, I create Phausto new. And then we say, for example, let's try with divided by 16. Like that. As the notes. To the name of the instrument was TP Uber. And then let's see if it works. So I can just add instrument, create my own instrument. I can save it as a package and they use it. So the way to use it, to use them inside the performance. Let me check. So I think we are down. I thought if we want to try a little performance together, could be fun, no? Yeah. So in the slide, you can do it now if you want, or you can do it later. But maybe it's better with you using Echo Fausto, so we have it ready. We can do it faster. But you can say this is. You can see this is a syntax to create a new sampler. So inside Fausto there is this turbo Fausto sampler, where you just have to define a path to a folder. So you give it a name and you give it a path to a folder, a full path. Or you can use Pharo methods to check for your document folder or for your desktop folder, whatever, or a path to file. So if you give it a path to a file, it's just a sampler with a sample. If you give it a folder, it's a multi-sampler, and you can use the index message like before. So you can put a lot of voice and change index 1, 2, 3, 4 in alphabetical order. And then you submit, you create a DSP, and you could create a performer just with 3 instruments if you want. You can say, I don't care, I just want to use my folder of sample, and I use them, I submit, and I control it because I know that the label works like that, so I can call it with the label. And, in the performer, we saw that you can mute stuff, solo stuff, unsolo. Then you can backup, that is like a temporary save. So you can do a lot of stuff, change stuff, and then restore. And also you can swap pattern, and then we try to do the performance together. I show you the last thing. So that's new. We'll go completely over there. Is a little message information. So there was no, I have to swap two sequencer identifier, but I was like, no, Banda doesn't exist, so it's not. Well, it's like, yeah. Okay. Now up to make noise. You can try, no problem. We try for the idea of the performance is that just not just the version of just we talking first, and then it's like to perform without synchronization. So this is the idea of extemporaneous music. Is with many programming like coding language, we have a way to synchronize different computers on the same net. In Coypu, we don't have it yet, but also I think that is interesting to search a kind of sonic pointing list and to try to synchronize listening to the sound that's coming from who is performing at our side or in the back. So of course we're using the speaker of the laptop. Will be more interesting with Bluetooth speaker or connected to the same mixer, and yeah, but we can try. So it's Echo Fausto start, and then list all instruments. If I don't remember. Or if you want to, you can also like start from the Coypu business card. So you can copy this on the repo and modify. The reverbs there come with Faust standard library. So you have a gray old reverb, a free reverb, you have quite a few stuff. So in effects, gray old, command B, I see is inside effect. So you have free reverb, gray old, saturation reverb, and zeta rep, that are the classical. So you just use it. Nice. More, yeah, because you can, if you start 10 Echo Faust at the same time, you are summing the same. It's creating 10 DSP, and DSP are summing themselves. Yeah, well, of course, these reverbs, and there are a lot of filters, because if you look at the filter, comp filter, old pass, chord filter, move, override, 1-0, resonator, butterworth filter. The standard library is kind of used. So if you want to use a butterworth filter and you say, okay, I probably don't implement it better than the Faust people that are doing this all the time, and you can use it. Otherwise, you should like write low-level stuff. You can, everything is a signal, so you can create like phasors and stuff like that with low level, just summing and with recursive structure. But I don't know if it's the best. And also one thing that we haven't seen that could be interesting before we start to perform together is that, let's go to the Fausto GitHub page. You can also create a DSP from a Faust string. So if you learn a little bit of Faust, or if somebody has done it for you, you can just take the string, create the DSP from the string, and you have the region. So sometimes it's more effective to write it in Faust and then create it with the string in Fausto. And then you can save it as your reverb, but create it from the string and reuse it.
What were you planning this?
The string, can you see? The string has to be a valid Faust program. So for example, let's say, you have to write a Faust program. Yeah. For example, you can go to if you want to see, just to check Faust libraries on GitHub. And you go here, and you want to see, look, this is how they implement the JC reverb, the classic John Chowning reverb in Faust, low level. The Faust libraries are Faust low level code, just with primitives and integer operation and recursive and connecting signals, and they are saving it in a library that can be used. So this is like the low level code that you need to write for a JC reverb. If you want to write UART, you can, for example, start from this and change the coefficient number. Very basic, you know, say, okay, I don't like this, I do it a little bit different, I change the numbers. And then you have different ways. You can save it in the folder with the libraries, or you can create, it's called a box. inside the Fausto, and just with a string of code, we create that, and you can use it when you want. Yeah. For that, you need a little bit more time digging into. There is some paper and in the resources where you can learn if you're interested in that. The idea was the idea was to combine the thing with the idea with Fausto was not like, okay, you use Fausto and that's all. The idea was like, maybe you start with Fausto because it's easier. And then you say, okay, maybe now I'll learn a little bit of Faust, do manual, and then you combine the two stuff. We don't have too much time to talk about the visual interface, and I also think it's a little bit too much for today, but we did a lot. So the visual interface is done in Coypu and Pharo with this Coypu IDE that is using Block, that is a low-level graphical framework for Pharo. It needs a little bit of time to learn Block. It comes with Masterloo or with Coypu. Either you can check the slide when you have a better internet connection, if you have interested in that. And that's, if you send a message display UI to a DSP, it opens a little UI with knobs and buttons. Or you can just ask a widget for a parameter, and you just have the widget for the parameter you want, like the tempo, for example, BPM. Or you can ask just a UI for the levels, display UI for the levels, and you got the level. Somebody was asking me before you, the other friend there was asking, how do I change the level of the sounds? Because some is very loud, something. So if you don't want to change it with the code, you open display UI for levels, you get this little mixer, and you change. And then also there is a way to create your own container and to add widgets. Very easy. It's like a line of code, and you can decide on type. We implement a different type of knobs. And again, if you look inside, you can look how it's implemented. They implement yours and change background and stuff like that. It needs a little bit of coding. If you want to join the community of Pharo, this is the Discord channel where you can ask whatever you want to ask to professionals and friends from all over the world about anything. I really thank you for coming here and having fun.